Now, before writing the fast NumPy coding, basic NumPy coding, whatever, you first of all need to import NumPy. And if you don't have, if you didn't install NumPy in your device, you just need to go into your terminal over here, and then just write over here pip install NumPy, pip install NumPy, and then click enter, and it will install the NumPy on your device. But for me it is already installed. You can see over here that requirement already satisfied, so I don't need to install it again. And then you can obviously import that NumPy as NP, because we don't need to write NumPy every time whenever we call it, so we will make it shorter, and that shorter term will be NP. Okay, so now to initialize a NumPy array, we already saw that you have to use np.array. So for first one-dimensional array, you just use this one, like a is equals to np.array, and that can be like first of all you just need to use a parenthesis, and inside this you can use the list box bracket. So and then we can use 1 comma 2 comma 3, and then if you want to print that, yeah, it will be an array. And in case if you are not using Jupyter Notebook, in that case you just need to write print a, and it will obviously print that particular array. And similarly, if you want to define two-dimensional array, in that case obviously you can write like this, b that is equals to np dot array. For example, this two-dimensional array is a float array, so we will use the parenthesis first of all, and then the first row, right? So this is the first row. For example, this is a floating array, so 2.1, and then comma 3.4 comma 5.6 and all. Then the second row. Okay, remember we should divide the two rows with a comma. So here you can see it is a comma, and then we will use another list, the second row obviously, and that is something like 3.9 comma 5.0 comma 7.8 and all. Then if you just print it, let me just print b, and okay, it's a type error. So it is showing a type error. That is because the whole thing is an array, right? So we have to put two rows inside a particular array, that, and for that we have to use the box bracket, right? So we have to put these two rows inside a box bracket, so we will use the box bracket. And now you can see, if I run this cell, you can see it is a two-dimensional array. And let me just write it like this, 5.1, so that, yeah, and I can print it as well, print b. You can see it is a two-dimensional array. So in this way you can declare a NumPy array. Now in case if you want to know the dimension of that particular array, in that case you can just write like this, a dot ndim, and it will show the dimension of that particular array. So here the dimension of a is 1, and similarly here the dimension of b is 2, right? So let me just write over here, this is for get dimensions. Yeah, and now if you wanna see the shape of that particular NumPy array, for example here for b, the shape is 2 by 3, because there are 2 rows and 3 columns, right? So for that you can just use this shape command, so shape, and let me just write over here get shapes, and if I run this cell, you can see it is 2 and 3. So the next one is for example, if you want to know that how much memory it is taking for a particular array, so in that case you can use this b dot dtype. And let me just write over get type of the array, or yeah, so it is by default taking float 64, because it by default takes float 64. Obviously we can customize it and initialize with a constant memory location, but for example, if you just want to know the type of a, then let me write over here a dot dtype, and it is taking integer 32, right? It is taking 32 memory allocation, but obviously you can customize it while declaring, because sometimes you don't need 32-bit memory allocation, that is actually equals to 4 bytes. So you can obviously initialize with like int 8, and that will be 1 byte. Yeah, you can obviously customize that thing. So if you want to see the size in bytes, so in that case you can use item size, and let me just write over here get size of the array, and it will show me obviously 8 because 64 is like 8 byte. And if I use this item size command over here, it will be obviously 4 byte. A is taking 4 byte memory allocation, so a dot item size, and it will be 4. But obviously you can customize it. I already told you that. So to customize that thing, you just make it over here like a comma d type. Like after declaring the list, you have to write d type inside the parenthesis. Remember that thing, you have to write d type inside that parenthesis obviously. And d type equals to, for example, if you wanna make it integer 8, that means 1 byte, int 8. So obviously it will create a particular constant memory allocation. And then if I run these two cells, you can see now it is int 8, and it will be 1 byte memory allocated, and that is 1. And yeah, you can see for item size it is 1, right? So it is taking 1 byte memory. And now if you want to see the total size of that particular array, so in that case you can use b dot size. So this will be the total size of the array. It is actually 6. So actually the total size will be like b dot size multiplied with b dot item size. So I'll just write over here b dot size, sorry, yeah, I'll do it over here, b dot size multiply with b dot item size, and that is actually 48. It is taking 48 bytes, and you can obviously do it b dot n bytes, so it will show you the number of bytes it is taking, n bytes. And let me just write over here total size of the array. This is part 2 obviously, so I'll just write over 2, sorry, yeah, 2, and it will obviously show the same amount because b dot size multiplied with b dot item size is the total size of that particular array, and that is equals to 48 bytes. So yeah,